By the end of this module, you will have a basic understanding on condenser water pumping application, how it works traditionally, and the Danfoss solution. The key benefits of using a VLT/HVAC drive in condenser water pumping systems. Let me start the module with a brief description of the condenser water pumping application. Condenser water pumps are primarily used to circulate water through the condenser section of the water-cooled chillers and their associated cooling tower. The condenser water absorbs the heat from the chiller's condenser section and releases it into the atmosphere in the cooling tower by evaporation. The cooled water collects in the tower basin, where it is then pumped back to the chiller condenser. We shall now look at a traditional condenser water pumping system. Traditionally, a condenser water pump continuously circulates the water at full flow. The temperature of the condenser water is determined by the cooling tower fan's operation. The lower the condenser water temperature, the lower the energy consumption of the chiller. However, the decrease in energy consumption is small, and reducing the speed of the cooling tower fans can save more energy. The condenser water pump continuously circulates the cooling tower water at a constant flow. The chiller manufacturer recommends the flow through the condenser section for best heat rejection. In any VLT/HVAC drive application to an existing chiller, this condenser flow must be verified to ensure compliance with the chiller manufacturer's requirements. Often, the condenser pump is oversized for a safety margin and requires field balancing with a balancing valve to increase the system resistance and to prevent too high a flow rate. Excess flow can erode the chiller tubes, increasing maintenance. In traditional method, there are two ways of controlling the condenser pump flow. Balancing valve. Trimming the impeller. First, let's see how condenser flow can be controlled by the balancing valve. In traditional solution, during commissioning, the balancing valve is partially closed to set the pump flow rate to the manufacturer's condenser water required flow rate. Typically, the pump is not operating at its best efficiency point. Take a look at the illustration. It shows the opening and closing of the balancing valve. When the balancing valve is partially closed, the pressure is increased, and the design flow is achieved. Similarly, when the balancing valve opens, the pressure is reduced, and the flow is increased. Take a look at the graph. It shows that, as the balancing valve partially closes, the flow decreases, riding the pump curve to a higher pressure and lower flow. You can also notice, from the graph, that, as the balancing valve opens, the flow increases with a reduction in pressure. Now, let's see how condenser pump flow can be controlled by trimming the impeller. Trimming an impeller means making the diameter smaller. The condenser pump flow can be controlled by trimming the impeller. The pressure drop at designed flow rate is determined, and the proper size pump impeller is determined from the pump curve. The impeller is trimmed to the correct size. However, this method of achieving a proper flow results in reducing the pump efficiency. Take a look at the illustration. It shows the pump impeller without trimming. You can also notice from the graph that the pressure is high and the flow in excess without trimming the impeller. Click on the Trim Impeller button to view the change in impeller size and the energy consumption. Here, you can see the reduction in the diameter of the impeller. You can also notice from the graph that there is a reduction in pressure and decrease in flow. Now, click on the Reset button. You can see a text indicating impeller trimming is irreversible. It means that if you want the flow to be increased after an impeller has been trimmed, then a new impeller of the correct size must be purchased and installed. You have seen that, in the traditional solution, energy is wasted by throttling a balancing valve or trimming a pump impeller. How can we overcome this wastage? That is where Danfoss solution comes into play. In Danfoss solution, the best energy savings are achieved by installing a VLT/HVAC drive to the system. Two methods of control can be used to control the condenser pump flow, improve efficiency, and reduce energy consumption. They are: installation of a VLT/HVAC drive on the condenser pump, operation of VLT/HVAC drive as flow valve to maintain a constant condenser water temperature. The most common method of control is to simply install a VLT/HVAC drive on the condenser pump. If a balancing valve is installed, it is partially closed to compensate for the impeller being too large and providing too much flow. After installing the VLT/HVAC drive, the system balancer simply opens the valve and sets the pump speed to provide the design flow. Opening the balancing valve in the pump discharge eliminates the artificial pressure drop, and the pump operates at a slower speed to provide the design flow as the pump operates along the system design curve. In Danfoss solution during commissioning, the VLT/HVAC drive is used to reduce the pump speed flow rate to the chiller's condenser water design flow rate. With this method of control, the pump continues to operate near its best efficiency point. Take a look at the graph. It shows the comparison of traditional and Danfoss solution. You can notice from the graph that in Danfoss solution, the pump curve rides down the system curve, and the pump is operated at the design flow. Thus, in Danfoss solution, a lot of energy is saved when compared to traditional method. Next, let's see how condenser flow can be varied with the control of condenser water temperature. The traditional method of control provides a constant flow of condenser water through the chiller. A second method of controlling condenser water flow is by using the VLT/HVAC drive as a flow valve to maintain a constant condenser water temperature. Chiller power in kilowatts consumption is minimum at the chiller manufacturer's recommended condenser, entering and leaving water temperatures through the chiller. The VLT/HVAC drive maintains the appropriate condenser supply temperature by increasing or decreasing the flow rate through the cooling tower. Let me show you how this is done. As the condenser water temperature increases, the speed of the condenser water pump increases, and its flow increases to maintain the condenser water set point. Similarly, as the condenser water temperature decreases, the speed of the condenser water pump decreases, and its flow decreases to maintain the condenser water set point. You can notice from the graph that as the condenser water temperature increases, the flow is increased with the pump operating at flow 2. Similarly, as the condenser water temperature decreases, the flow is reduced with the pump operating at flow 1. Care must be taken with this method of control to avoid low flow through the chiller condenser. This can typically be achieved by using the minimum speed setting of the VLT/HVAC drive to control pump flow. We have said that a VLT/HVAC drive improves the pump efficiency and saves more energy than trimming a pump impeller. Let us see how this happens. A pump manufacturer plots the efficiencies for a pump with different impeller sizes to help the designer select the proper pump with a high efficiency. Take a look at the graph. It shows the pump impeller and pump efficiency curves. Please notice the best efficiency point for each impeller shown on the graph. Operation above or below this point is less efficient. An example of trimming an impeller is shown in blue point and red line. A pump with a large impeller would deliver excess flow at higher system total pressure. By trimming the impeller, the size would be reduced to the middle impeller size. The point of pump operation would move diagonally to the middle impeller. The efficiency would reduce from 85% to 80%. Take a look at the graph. It shows the pump best efficiency curve. When a VLT-HVAC drive is installed, a new series of pump curves at various speeds is created for each impeller size. The region of best efficiency lies in the system curve that passes through the origin. As the pump slows down, it moves down the system curve, and the efficiency remains constant at 85%. Because the pump efficiency is higher, less energy is consumed compared to trimming the impeller. We just saw that the Danfoss VLT HVAC drive facilitates energy saving in the application over using balancing valves or trimming the pump impeller. The first step in calculating energy savings is to determine the power consumption with the existing balancing valve partially closed or by trimming the impeller. Taking electrical measurements or using a pump curve provides an estimate of power kilowatt used. This power consumption is compared to the energy required by using a VLT HVAC drive. Take a look at the graph. It shows the existing condition as using 100% power versus a reduction in power to 65% by reducing pump speed to provide design flow with a VLT HVAC drive. Multiplying this power difference over time provides the calculation of energy savings for installing a VLT HVAC drive. To calculate the potential savings over time, the actual load versus time profile must be known. The load profile indicates the amount of power a system requires to satisfy its load during the time period of study. The graph shows the energy consumption over time for a typical load profile of a condenser pump. The profile is flat because the pump provides a constant flow to the chiller. The difference in area is the power over time used by the pump when running. The VLT HVAC drive saves energy by removing a pressure drop across the balancing valve or by running the pump at the best efficiency compared to trimming the impeller. The profile varies depending on the specific need of the system and geographical location. Let us summarize the main benefits of using a VLT HVAC drive in condenser pump systems. VLT HVAC drive eliminates the pressure drop of the balancing valve. VLT HVAC drive provides higher efficiency over trimming the impeller. Energy savings are simple to estimate by using a VLT HVAC drive. Before ending this module, let me give you a brief summary of what we learned. In traditional method, we have seen that the use of a balancing valve and trimming an impeller lowers energy consumption and reduces the pump efficiency respectively. But we saw that, in Danfoss solution, the addition of VLT HVAC drive is used to reduce the pump speed to set the pump flow rate to the condenser design flow rate. We also saw the key benefits of using VLTH VAC drive.